Here are two ideas that pertain to circles. The first is called RPT. A radius is perpendicular to a tangent. And let's see what that looks like. I'm going to first create a circle, and just so I can sketch a tangent line. Remember, a tangent intersects a circle at a point. And so that looks like it might represent a line that's tangent to that given circle. And so what I'm then going to do is create from the center a radius that shares the same point of tangency. So we have a radius here. Here's our little radius, and here's our tangent. Okay, but more importantly, they share all three. The radius, the tangent, and the circle all share this point in common. It's called the point of tangency. And so what this idea says is that that radius is perpendicular to that tangent. So we have boom and boom. Okay, and another way to think of that is if a radius hits or intersects a tangent, then they meet at right angles. Okay, that's kind of, to me, what RPT says. And we can basically assume that to be true, or we can prove it later. But for now, we'll just assume that it's true, and because it looks like it ought to be true in this case. Okay, so for any tangent line to a circle, if a radius does in fact hit that tangent, okay, and by hit I mean share this point of tangency in common, then they do so at right angles. All right. Obviously, this radius here doesn't even hit this tangent line, so they're not going to meet at right angles. So there's only one point at which a radius will hit this tangent line, and that's with this particular radius here. Okay. The second idea is called the two-tangent theorem. Okay. And here's what this guy looks like. So I'm going to start with a circle, and I'm going to create some point outside the circle. That's called an external point. Now what I'm going to do is from that same point to the same circle, I'm going to create two tangent lines, right? Both of which are tangent to the same circle from the same external point. And if I actually did create two tangents rigorously, then what you would find is that those two tangents look like they are, and indeed are, congruent. So these guys are congruent. Some people call this birthday hat. You know, it looks like a little birthday hat. And those two tangents create a little birthday hat. Here we go. And of course, the circle is the face. So these guys are congruent. That tangent is congruent to that tangent. So the way we would say that is two tangents to the same circle from the same point, external point. Right, here's the same external point. Oh. Right, they both originate from that point right here, A, and they both are tangent to the same circle. Then if that happens, they are congruent. Okay? So two ideas here. One is RPT, radius. If it hits a tangent to a circle, they meet at 90s. Radius is perpendicular to tangent. And then the two-tangent theorem. If we have two tangents, right, to the same circle from the same external point, A, then these two guys are congruent. Okay? RPT, two-tangent theorem. And we're going to use those tomorrow. Okay, so understand them so that we can apply them tomorrow in a bunch of different situations.